Hello
Okay.
and welcome to session 324 in the AIsafety.com reading group. Tonight, Lau Mein will be discussing the Titutels article with a critique of AI 2027's bad timeline model. Lau Mein, pleased to have you. Take it away.
All right. All right. Thank you. I'm going to be referencing a lot of different papers in this. So if anyone has any questions, please speak up immediately. Yeah. Yeah. I might be going over a lot of things, assuming that everyone knows or just forgetting that something isn't common knowledge. So yeah, definitely stop me if at any point I'm unclear. Okay. So starters, what is AI 2027? It's a relatively popular scenario about how our world can create artificial superintelligence, ASI, by 2027, just by following existing trends. The summary of what goes on in the story is that you have a combination of things like current hardware investments and algorithmic improvements, that is, software research that makes our current AIs more and more efficient, requiring less compute. This allows for the proliferation of large language model agents, which then do AI research, and that feeds upon itself until artificial superintelligence is achieved by the end of 2027. In this scenario, there's an AI race between China and various US AI firms. Nothing really major geopolitical events take place, although China steals some frontier models. And very importantly, no consolidation of major US AI firms takes place at all. You have like five different competitors. They all roughly have the same compute, which is a really interesting assumption. And then, yeah, there's like a good ending where there's an AI treaty between the US and China and everyone lives happily ever after, and a bad ending where everyone dies. Okay, so
Just one quick clarification, since you asked for it. So there's no consolidation in this scenario up until the end of 2027, and that's the
no,
last.
yeah,
But that's the point where the last point where humans can influence our destiny. But the scenario actually continues further for 3 years, and I believe in both the good and the bad event there is in fact this consolidation, but it ends up not mattering because it's after
yeah,
2027.
yeah. I mean, right, yeah. I mean, it's like there's no consolidation while like the massive race time. Yeah, basically, you're right. Okay, so people have seen this, and there's a lot of critiques, and one of the most common ones. Well, one of the most commonly read ones is called a deep critique of AI 2027's bad timeline models. And in this, he just like plays around with different parameters and shows that like if you start with really absurd assumptions, like changing the initial time horizon, like the current time horizon, to 15 nanoseconds instead of 15 minutes, you still get very similar outcome distributions. And the like all of these problems with the model that AI 2027 presents is comes from two major factors. The first of all is using the time horizon as the primary measure of agent capability. And then there's the assumption that doubling each time you double your time horizon, the next doubling time gets shorter. And they make some arguments to this, and I'm not convinced. But moving on, in this critique, they note that the meta paper, which references the time horizon, the entire time horizon method is based on a very particular meta paper, right? And it compares the performance of AIs and how it's increased over time. But the guy who made the critique didn't actually read, well, he didn't dig very deeply into the meta report. He thought it looked okay, though. There's nothing that's obviously wrong with it. And then I read the post on Less Wrong, and people commented about it, and they didn't really notice anything obviously wrong with it. And I just completely disagree. So, for starters, there's a very straight line, and it immediately reminded me of a classic Ray Kurzweil line, right? And it has all there's so many different degrees of freedom. So in Ray Kurzweil's line, it's time to next major event, and it goes from like the start of life itself to the present day, and the line is almost completely straight. How did he achieve this? He had infinite degrees. Well, not infinite degrees. He had a lot of degrees of freedom. That means, like, he basically got to define events and like kind of like nudge it a lot. Basically, he could make the line as straight as he wanted, right? Like he could definitely have made this line even straighter if he really wanted to.
So
And that's the
I
base.
can I just push back a bit? If I remember,
Yeah.
Kurzweil's original methodology was he went to a lot of scientists and similar people. I can't remember exactly who. And then the question is, could you tell me what are the most important things that have ever happened? And so that's like the question that was posed. And some people said multicellular life was the most important, and some people said the printing press. But that was how he gathered all this data. And I mean, it is that's not that many degrees of. He didn't choose these things himself. Other people did.
Okay, I actually didn't remember that. I just remember making fun of them for it.
I'm
So
75% certain. There is a chance that I'm wrong, but that's the methodology I
yeah,
remember he used. And
yeah,
yeah, it's a pretty straight line. Yeah, I agree with that.
yeah. Okay, we obviously disagree here, but I still think it's too suspicious, right? If you're logistic regression, okay. And the reason for this, actually, I'll get to later because this is actually a This isn't a single assessment. This is a composite of three different assessments, and yeah. So let's look at that. First assessment, SWAA. This is very simple tasks that range from 1 to 30 seconds. It includes things like very basic multiple choice problems, right? Like current frontier LLMs, like whatever ChatGPT model we're on, Claude, R1. Yeah, they have basically a 100% completion rate for these. GPT-2 has a 50% completion rate for the 1 second tasks, which is insane because like they would it like I would expect it to give invalid answers to like a multiple choice problem. If you go, here's a question, here's A, here's B, here's C, I would expect it to just like respond with D because that's like continuing the pattern or whatever. So yeah, I haven't tested this yet, but I find it very suspicious. Okay, the harder assessment is HCAST. You have a bunch of standard coding tasks that range from 1 minute to 30 hours. So yeah, the vast majority of the difference between the models comes from differences in performance in the HCAST um, benchmark. Also, they include one problem from Gaia, a completely different benchmark, and five coding problems of, I think, unspecified origin, and this was done without justification. I don't know why. I think it's suspicious. Yeah, and these are meant to be like sort of real, quote unquote, realistic programming tasks that can add economic value. Basically, it's like leak code, medium to hard problems. The very hardest ones are like in their own category and closer to Rebench, which I'll get to. So Rebench is extremely weird for this because this everything is for the previous plots are based off of a pass fail system, right? So it's like, can you complete this task? Can you guess the which um, algorithm is running when you're allowed to like only test a few inputs and see the outputs and make hypotheses or whatever. Yeah. So Rebench is completely different because it is actually benchmarked off of human performance. They have very good human experts, which I assume were in-house because everything else is in-house more or less. Well, sort of. I'll get to that later. This was designed to be a benchmark for recursive self-improvement. It's designed to assess how good a LLM is at like really, I don't want to say frontier model, but close to frontier, very complex machine learning research. So you would give it like the simplest ones would be something like, oh, you do a class, you make a classifier and like try to optimize its performance. And so the thing is, they just gave a human being 8 hours to complete this and then said, okay, we'll put this in the 8 hour category. And whether you passed or you failed is based off of if you did better than the geometric mean of the human experts, which, yeah. Yeah, so basically it means can you do machine learning research better than the average human machine learning research expert? And predictably, I'm pretty sure there's like almost a 100% fail rate for a rebench. I'm not 100% sure though. There's some like they use a slight a less binary assessment possibly for another thing. I'll get to that later for my next presentation. Yeah. Anyways, so yeah, how did they determine the time horizon value of a particular task? SWEE, which is 1 to 30 seconds, the 1 second to 1 minute or 1 second to 30 seconds, something like that. They just had employees do them. HCAST used mostly friends of employees who were like programming, who are like professional programmers, or and they had to pass a screen where they had to show competence in like cybersecurity and or like machine learning and or Python coding or whatever. And for the HCAST assessments, roughly more than 20% of them had zero completions. Right, out of 97, 21 had no one able to complete them in any amount of time, which is pretty interesting. And then in these circumstances, they just had researchers give their estimates. And these estimates are oftentimes wildly wrong for various reasons. But yeah, and then they included those in the assessment. I'm not sure why they did this. I think that just makes the data a lot more noisy because and more complicated for people. It is complicated. Anyways, so on the left, let me just give you a general feeling for how well the humans performed, right? Because um, so time horizons are the two numbers I've seen used pretty often for time horizon. Well, in this paper is 80% and 50%. So what is the time horizon for a human being? Well, the 50% time horizon is something like 1.5 hours, right? It's like half an hour longer than our current best large language models. The 80% time horizon for a human being is actually closer to like 5 minutes, which I'm not really sure how to respond to that. Like, I'll get to the specific examples later, but yeah, I'm updating really heavily on future unemployment for human programmers, but
So can I come with a possible interpretation of this?
yes,
That
yes.
when a human has been programming for 5 minutes, it is 80% probable that he has not introduced a bug. And when a human has worked for, what was it, 1.5 hour, then it's more than 50% likely that he has introduced a bug and so
Oh no,
doesn't complete this. Is this?
this isn't like you don't get just one try. You get like some test cases, and you can write your own test cases, and you can like um it's very much like a leak code problem, right? You have the test cases, and then you can like um try really hard to make sure that things that like your code is correct. Um yeah, do you does that answer your question, or
I think roughly.
do you see?
I'm still a bit confused about like uh, what precisely we are measuring here. But I think like the general gist of it, like at some point people give up. I guess that's how they fail, right?
Yeah, and the thing is, I think they get paid like I don't know, $50 to $100 for each correct answer.
Hmm.
So like, there's a really high incentive to like get all of them correct. So there's that. But like they did mention that based off of the way they pay people, a lot of people gave up, even though they were on the right track because it was taking up too much time. And like the specific equation they gave for like compensation might have incentivized people to like give up relatively quickly on the harder problems. But like it like I don't know, maybe it seems that what I found most unexpected about this was how poorly people performed at like the lower end. But maybe that's more just like not everyone knows the every data structure ever, and they don't really know what to Google for if they don't know structure because I don't know. We'll get into that later. Well, actually, we won't. But anyways, my assessment of this, um, the hold is sigmoid, right? Like they have three different types of assessments, and you have completely different performance regimes for each one of them, and then you try to do a sigmoid regression on it, and you get like this. Like, come on, that you have to, obviously I'm cherry picking this. I think, yeah, a lot of them look much more sigmoidy, but it is pretty funny. Anyways, every single frontier model did very well on SWAA, right? Like earlier GPT-4 iterations and earlier Claude 3 iterations, like had less than 100% performance on like the tougher ones, but O1, Claude 3.7, basically 100% completion rate. So that's not really accounting for much of the difference between the different models. Um, the real difference in performance is in like GPT-2 and GPT-3, right? So GPT-3 is better than GPT-2 at the SWAA, and GPT-4, like earlier iterations, are considerably better than GPT-3 and GPT-2. Like the thing is, the only information this is adding is that like I'm saying the only reason the only value SWA really adds to their assessment is that it helps you put GPT-2 and GPT-3 onto the graph, and they acknowledge this in the time horizons paper, and they have like a different assessment, like a different plot where they remove GPT-2, GPT-3, and SWAA completely. And that doesn't really take anything away from it. So I'm just wondering why they like included SWAA in this assessment in the first place. Um, Also, error bars go from 0% probability, but I wouldn't fix that either. Um, because yeah. Anyways, let's take a look at some examples of problems. So first of all, here's a red flag. Only 61% of our human baselines were successful. Um, that's a thing. I didn't expect that. I expected like just much better performance. Like these are supposed to be professional programmers at like I assume what was it? The group Meter. I assume Meter is a pretty competent group, and their friends are mostly competent programmers. I don't know. Here's an example I was talking about earlier. It was like, okay, so you have like two different PDF files and some like doc files, and they have this like I'm not even sure if this is a real thing or not, but they describe they're basically research papers, right? They're like 100 pages, and the estimated time for this problem is what you're supposed to do is you're supposed to write a one-line regex function. You're supposed to find the places where these buzzwords appear, and then you're supposed to like look through them and do basic reading comprehension, right? What actually happened is they had three different attempts by humans. Only in one of them did the human actually do the regex. The other two attempts took an hour. I assume they read through the actual PDFs. Remember, this isn't they didn't do this on a computer. They didn't do this on like a desktop environment. They did this through like command lines. So they like I guess maybe some people just couldn't figure out regex and stuff like that, and they just like had to um, read through the PDF line by line by importing it as a TXT file or something. I don't even know. But yeah, they were compensated for this, and also they could Google like all of this at any time. They just couldn't use an LLM for it. Um, so yeah. Anyways, the compensation. There was like an exact equation that I'm not including, but yeah, the longer the average participant took to complete a particular problem, and the shorter time you took, the more you got paid extra. So then we have a very tough one, right? This is basically you're supposed to make adversarial white box adversarial attacks on an image classifier. It's supposed to only take 7.5 hours. I'm actually doing something similar to this for a resume project, and it's taking me like a month. And yeah, that's worrying me. Any case, but yeah, let me go back. The HCAS data set only released 11 problems out of the 97. It was released after the Time Horizons paper. So like a lot of my criticisms, like what humans only have, like it's really hard to criticize the Time Horizons paper without understanding exactly what's going on with the HCAST, and the HCAST paper was released after that, and like people stopped caring about the Time Horizons paper. So yeah, th this paper didn't get very much buzz when it was released. There's that. Any case, so what's Rebench? Well, it was released before the other papers. It was released in November 2024. It was specifically designed so that current LLMs at that time had a low score, right? They didn't want the benchmark to saturate too fast. Human level performance is by definition a high score, right? They had humans grinding away at this problem for 8 hours. If they had a problem which current LLMs did better than the average human performance, they wouldn't be able to include it in this because it violates their criteria, right? It would just be immediately saturated and it would accomplish nothing. So like model performance, like in Rebench, I don't think improved very much between the publication of this paper and the publication of the time horizons paper. So like they chose this as a criteria knowing that frontier models would get like 0% performance. So what does this add really? It doesn't really add anything to this paper. So what is my assessment? Yeah, like I mentioned before, um, is it the SWE or SWAA? I think it's sub. I didn't even forget. Anyways, yeah, it's like they're trying to make the implication, right? Okay, here are some lead code problems, right? They take the average human being 5 minutes to an hour to complete. The really hard ones aren't in their own category, but that's different. They're like, so it's like, okay, we have these lead code problems, and current frontier models are getting better and better at doing lead code problems, right? And then I use SWA and Rebench to like extend the the time horizons thing because then you can just say, oh, it's not just they're getting better and better at specific lead code problems. They're getting better at like their time horizons, right? It reframes a problem. In reality, like they're not really improving at the Rebench problems, and they're not really improving at the SWAA problems other than like very early GPT-2, GPT-3, but that was, years ago. So they're like making the implication that, okay, this is actually part of a much bigger trend. But my assessment of the situation is that doing leak code problems really is just very simple combinatorials, right? There's like literally millions of web tutorials for these types of problems, not the exact ones, but like obviously an LLM can think of okay, here's a problem I saw before. Here's a problem that's like this the problem I'm seeing in front of me reminds me of this tutorial I saw before. And then it lists like I assume it lists like 10 different problems, and it's like, okay, how can I like combine these together to find a solution? A lot of human beings do this in real life, right? They copy and
Mhm.
paste code they find on the internet. They literally can't like do foobar, right? But they still get hired as computer engineers somehow. Like it's a legit way of solving these type of problems. But those people like will need to completely learn. They'll need to do something completely new. They will need to actually learn how to code if they want to do frontier, you know, ML research, right? Like yes, you could grind away at like being able to combine online web tutorial stuff and occasionally get a breakthrough. By the way, let me show you something. So yeah, look at this again. Look at the performance again. Look at the performance for the tasks longer than 1 hour. Can you guys see that clearly or no?
Can you point precisely where you are looking at?
Okay, so 1 hour,
Yeah.
right? You see this red line?
Yes.
That's a line from 1 hour. On the right are tasks that take longer than 1 hour. On the left are tasks that take less than 1 hour. So look at Claude 3.
Hmm.
Look at different Claudes, right? You see
Yeah.
that little L shape here? That
Hmm.
L shape, L shape, L shape, L shape. These are different models, right?
Hmm.
You have GPT-4 and Claude, and they're both have that sort of L shape, like it's slightly
Hmm.
bigger as the model improves. Um, my best guess is that these are like slightly misclassified problems, possibly the ones that like the humans like rated, but they just like no one was able. I don't even know. Like these are very specific problems where if you're an LLM, you can find a clever solution. I'm sure if you're a human, you can. what I'm trying to say is these represent problems which probably have like a simple solution that the people who wrote the problems just never thought of, right? And occasionally the AI bumps into that, but like the fact that it's like the same few problems, like you notice that gap between the L shape and the rest of the
Yeah, that's
distribution,
pretty
that's
strange.
that's that's empty for every single one, which means that none of them got a single one of those. Like even occasionally, they ran that like five. Like think about what that means. That means
Hmm.
like you have problems that are rated as like 1 hour that like 1 or 2 hours that like 0% solved, and then you have problems that are like rated at 4 and 8 hours that like these programs could solve like 10-20% of the time. It's like specific problems, right? Maybe one, two, three, four problems that like could be solved by LLMs, because they know an esoteric data structure, or maybe they import a library and like or they use like NumPy and like just use the efficiency of C to like brute force a problem instead of like I don't know, making a segment tree or whatever. Like you can just do that. You can a lot of times like on leak code, you can just do a brute force strategy and it turns out that just like takes 15 seconds and it passes the assessment. You can just do things, it turns out. So yeah, it's like if you so that L shape makes it very suspicious because if you discount that, there's like you see that hole. Like there's zero progress made from GPT-2 to Claude 3.7 in the like 2 hour hole. So it's like it's very possible that other than finding a very particular trick that the writers of the problems haven't thought of, they made literally zero progress for problems that take longer than 1 hour. Like that is a perfectly valid assessment of the data, and I think that's what's going on. So it's like, okay, I think that feeds into my assessment that yeah, they're just getting really good at like copy paste, doing combinatorial copy paste. What do you even call that? Like the copy paste coding that people do? Is there like a name for that?
Uh, I don't know. I also just call it copy pasting code, or um, but uh,
Yeah.
I do have there been like I think I'm when I look at these graphs that you're showing, I do see some
Mm.
improvement also on the more difficult problems, right? Like these graphs
Well, yeah,
are substantially different
but for
as you
more
move.
difficult problems,
I
well,
mean, yeah, but it does appear from these graphs that
mm,
more capable models do in fact perform substantially better.
generally only on H task problems, right? The ones that are like 5 minutes to an hour roughly, right?
Yeah, uh, I think if you look at, for instance, the lower right button, the lower right
Mhm.
from Da Vinci here, that does
Yeah.
seem like it fails like even the simplest, there are none they can uh, that can be handled.
Yeah.
Whereas if you take Claude 3.7 Sonnet, then it takes basically everything up until almost like what's that? I can't quite see 5 minutes. The five
One
minute
it
mark.
1 hour. 1 hour.
Not quite, I think, but yeah. I mean, it,
It's offset in a weird way because like it starts at 1 second, but it's like there's a white. I don't know.
yeah.
Maybe I should ask the writers. But yeah, like you do sense that something is off about this, right? Like
Yeah, but on the other hand, it feels like a very reasonable thing to expect. Like the models are getting better, right? There is no way
yeah.
around the fact that Claude 3.7
Mm,
Sonnet can do something that Da Vinci
mm.
in the lower right corner just would never be able to do. Um,
Yeah, but it's like, but you do see the formation of a wall. You see the
mhm,
distribution of the data, and it's like, if it was true that if we would expect their time horizon to like double in like the next 6 months, you would see like you wouldn't really see that hole. Like,
mhm.
and I think that the stuff like that is fundamentally due to mashing three different criteria together and like the phase shift between I don't know
Mm.
copy paste coding and like actual creative coding that like current models can't seem to jump through. And it's like yes, you can make the argument that eventually they're going to overcome that. I fully expect them to overcome that. I'm just saying that like you can't just use this data that the pricing looking at right now as like clear
Mm.
evidence that we have a smooth increase in time horizons, right? Like this is what the entire AI 2027 paper is based on. I'm just saying it's the foundations are flawed. There are different interpretations of the data, and like if you feed in different interpretations, you get a completely different outcome. So yeah, and I'll again, like the example of three different criteria mashed together, and it's like looks completely. It's like a step, and yeah. Rebench. Okay, so yeah, this right. Infinite time horizons. Like they brought up the guy who wrote the critique brought up the idea of infinite time horizons, but like again, human beings don't have infinite time horizons. Human beings have like 5 minutes to an hour and a half time horizons.
Yeah.
So uh, although the the distribution does level off very differently. I think that's also another point, I should bring up. Like human beings don't have the dramatic drop off. It's like human beings and these AIs are relying on different mechanisms, and it's like humans have this thing where well as the problem gets harder you gradually have a decrease in performance. You get the problem like you have bugs and that you can't catch, and like as the problem gets tougher and the time horizons increase, you know
Mm.
um there's a gradual decline, whereas because if you notice the HCAS problems do include problems with really long time horizons, like 4 hours, 16 hours. They're all in there. I'll get it. Actually, these are actually based off of like expert estimates. Like the HCAS paper generally uses expert estimates for their task length instead of like actual human performance, which I find extremely weird. So maybe we're looking at complete different stuff. But yeah, um, it's not even necessarily the difference between HCast and Rebench, and more just past 1 hour you go from like um leak code problem to like actual ML research, and that transition just requires a paradigm shift for or vastly increased scale, or maybe that's the same thing, who knows. But yeah, right. I think I made all these um, points already. So yeah, I
So
think
I
something.
have a general question about like the conclusion from this. Like, what conclusion are you drawing from this? Can you just go back a bit?
Okay,
Like, assume
so I'm just saying. Okay, go on.
if you go back a bit further to the graphs we've been looking at, if the if Metro had designed their experiments better, would you
Mm-hmm.
expect this graph to be like more smooth, or do you think a better
I
experiment would reveal
my
a
gut
wall?
feeling is that this was like intentionally badly designed. Like
Hmm.
listen, I work in Chinese academia. I know when people are trying to p hack. Like I am getting the same vibes here. Like you don't do stuff like this by accident, right? You don't include a you don't like put three test criteria together and have one test criteria that like you personally like. I think there's a lot of overlap between the different authors for
Hmm.
the Rebench paper and this paper. They're using in-house assessments, by the way. Meta made
Hmm.
the HCAS assessment, they made the Rebench assessment, they wrote this paper. So yeah, like you don't do this by accident. These people
Hmm.
like talk to each other. They eat lunch together. Like they show
Hmm.
like if you showed the Rebench paper people this these graphs alone, they would have been like, wait, are they getting 0% performance? Because based off of your criteria, that's exactly what you would expect. Why are you even including it? So it's like it's stuff like this.
Mm-hmm.
Um, I think they're doing it intentionally, because straight lines look cool, I guess. Like it's
Mm-hmm.
obviously a huge accusation to make. It's fraud. It's fraud. But like, you know, that I'm not making an official allegation, legally speaking. I'm
Mm-hmm.
just saying that these are the vibes that it's giving me, and I welcome them to respond to the post I'm going to make about this. Uh, and I'm going to use less accusatory language. But yeah, in general, like doing this research gave me really, really bad vibes. Like
Mm-hmm.
AI 2027 gave me really bad vibes because there's like very obvious courses of action. Like the obvious thing you would do if you were China in this scenario is you will launch a missile strike on Taiwan. You don't try to take over the island. You don't,
Mm-hmm.
threaten anything. You just blow up the fabs. That way, the
Mm-hmm.
United States can't get any more chips, which damages the United States more than you. If you were the
Mm-hmm.
United States, if you're the president, if you're the people in OpenAI, even if you were in like XAI, right? Like Elon Musk looks at the situation, he says, "Wow, it looks like OpenAI is going to win. How about I'll do a stock swap with them? That way, we both win. They get our our TPUs and accelerate the product faster, and then they get like 6 months lead and beat out the Chinese, even while like racing and like doing safety research. It's like the whole everything is bizarre. Why do you have like six different US AI firms like all have roughly the same amount of compute? Like, but
Mm-hmm.
OpenAI is like the firmware. It's again, it's bizarre. And it's like it's obviously very much setting up a scenario where the only reasonable course of action is to sign an AI safety treaty with China. But like,
Mm-hmm.
I feel manipulated, man. And like my gut feeling is this is like a persuasion piece. It's not really used to inform people. And I fully expect way
Mm-hmm.
more of this as we go closer to AGI. And this is fucking terrible. This is like what AI safety people spent the last 10 years trying to prevent. But if you're playing iterated prisoner's dilemma,
Mm-hmm.
you play 100 games at prisoner's dilemma. The next game is the last one. You defect, right? Like that's a game theory thing to do,
Mm-hmm.
and rationalists like game theory. So I'll analyze AI 2027 further in my next presentation. But yeah, like I would take away the extremely low and just say I have low expectations. These are giving me bad vibes. Is that fair? Probably not. Um, but that's just my assessment. Anyways, oh, and by the way, the AI 2027 people used an extremely weird figure for their favorability ratings of OpenAI, and it's like these horrifically leading questions. It's like, recently they strangled puppies to death. What are your opinions of OpenAI, which recently strangled puppies to death? You get like negative 25%, but more neutral surveys generally have OpenAI at like plus 10%. Um, so yeah. Anyways, that's that. Questions?
Yeah. Okay. So you are of course right that there are a number of rational things that the AI 2027 scenario does not include, including things like missile strikes on Taiwan or consolidation. And I think you also said like a stock swap between some of the holders. And people are right now literally not doing this, right? So the assumption that they will continue to not do this for the next 1.5 year
Well, no, because
seems
it's
pretty
not
reasonable.
clear that there's a front runner yet. Like it's entirely like we're really not at that point yet where we have recursive self-improvement. If we find out tomorrow that like OpenAI might openly announce tomorrow, like literally, I think a chat, sorry, GPT-5, they're like
Hmm.
making all these like posts on Twitter that like something big is coming. The number
Yeah.
5, it means something. Like, it's honestly like really fucking cringe. But the point I'm trying to make is that if they genuinely show we have like these agents that are making significant like massive contributions to you know AI research, then yeah, I would be surprised if there wasn't a merger with OpenAI by a major US firm. If you count XAI as major, wow, that doesn't really matter, but I'm just trying to make a joke. Go on.
Yeah. Um, so I guess my point is that uh, this assumption that China has not woken up and the United States government hasn't woken up, it's true right now, right?
Yeah,
Uh,
yeah. Well, I mean, it's been like 2 months. It's been 2 months since they published the paper.
yeah, but they should have realized this like a decade ago, right? When the book Superintelligence was written, they should have realized this. It's just so happens that Xi Jinping did not read Bostrom, and neither did Donald Trump, and they
Well,
will continue to
Donald
not read.
Trump, Donald Trump, I would be surprised if neither of them have read um, Nick Bostrom by now. And Donald Trump has definitely read situational awareness.
Uh, Possibly, but like they're not putting this as the highest priority. I believe Donald Trump is more busy golfing, and I have no clue about what Xi Jinping is doing. But Xi Jinping is not acting as if he is AGI pilled right now, right?
Yeah, but
Um,
again, it's only been 2 weeks. Sorry, 2 months since like they dropped the paper. So that's well 3 months since they
mhm.
dropped AI 2027. So it's like 3 months later, the world looks mostly the same. Yeah, okay, that's true.
Yeah, so I guess one thing that could totally happen is that because the AI 2027 uh, paper website was written, then people behave dramatically different because they recognize which direction we're going, uh, which isn't like an obvious critique of that paper. Like I think most prediction papers are made with the assumption that, like counterfactually, that prediction does not exist, right? Did that make sense?
Maybe. I mean, it's like no one makes significant no one makes a write-up saying that AI is super duperly important. Like that vague category.
Hmm.
I don't know. Like their model is too vague for me to even like comment on that.
Hmm. Okay, so I have another question. Are you still sharing screen, or should I share screen? Um,
You can share screen.
I'll share my screen. You should be able to see my screen in a moment. Because like my question basically is, here we have this uh, graph here, and
Mhm.
I think you're right in that there are parts of this that seem kind
Mhm.
of questionable, but there are also
Mhm.
like uh, it feels like a lot of these things like are really happening, right? There is a sense that progress is not stalling. Or do
Mhm.
you believe that like this graph here, if they hadn't made these different errors, it would be flattening out? Are we seeing a flattening out here?
I don't think we're quite there, but like I think we're right at the point where um I think we're right at the point where it would flatten out in like the next couple of months if GPT-5 doesn't drop. And when they were writing this, it was not obvious that Sam Altman wasn't making cryptic posts on
Hmm.
Twitter about five. So it's like it's much less obvious that GPT-5 would drop. So yeah, yeah, I don't know. It's a tough question. I'm just saying that using the time horizon as your primary measure of AI capabilities is like a bad idea because
Hmm.
like it's shaky and it doesn't really extrapolate into the future because of the reasons I gave. So like
Hmm.
I'm just saying that because of that, um, their predictions should be a lot fuzzier, especially the prediction about doubling time. Sorry, about what's it called, refractory times, about like how much time like they're expecting the time horizon doubling times to decrease by 10% every doubling. And I'm saying that you can't expect that. In
Yeah.
fact, I expect the next couple of doublings to actually be vastly, well, not vastly, but like significant, like take significantly longer than the previous doublings because you're running into all these problems, because you're like need a new paradigm shift, so on and so forth. So I'm just saying
Hmm.
that specific prediction, which produces a lot of the really weird results, really weird predictions for the AI 2027 model. Um, that cannot be extrapolated from this paper. In fact, this paper, sorry, what I'm saying is that they're vaguely like saying that there's no real evidence.
Hmm. Yeah.
I don't know. They don't make a very good argument on why you should expect the doubling times to decrease
Hmm.
continuously, and I'm making an argument that I expect the doubling times to increase. So like if you change that one variable, it goes from AI 2027 to AI like 2029 or AI 32. Or AI 2032, and like I think that makes it a much more reasonable model.
Hmm.
Um, and I think that might be my primary gripe with AI 2027, really. It's like this one thing which they
Hmm.
don't justify very well, which they based on like kind of bad models, and
Hmm.
which I expect to be completely different. If you change that one thing, you get a much more reasonable model. That's what I'm
Hmm.
saying.
Yeah. And I think I also have a substantial disagreement with that part. Like Nick Bostrom in his 2014 book Superintelligence splits this
Mm.
question of the intelligence explosion into two. One is called optimization power, and one is called recalcitrance. Um, and optimization power is the thing that we're mostly talking
Mm.
about with this. That suddenly it's not just the humans at Open Brain that are improving the AI, but also some AIs in Open Brain that are also improving themselves. And
Yeah,
that's one thing. The other thing is recalcitrance, which is a word that hasn't really gained uh, a lot of currency um, outside of Bostrom's book, and that is roughly how much more difficult does the problem become as time goes on. Like, is it much more difficult to go from a time horizon task of 5 minutes to 6 minutes compared to going from like 5 years to 6 years or something like that? And
see, yeah. See, the thing is, I actually agree with them on the broad strokes of it. Like, I think once you get past this hump, I would expect it I would expect the doubling times to actually decrease. It's just that
mhm.
like over the next hump, like getting from like 1 hour to 8 hours might be vastly more difficult than getting from like 8 hours to 1 year.
That's actually
Like,
strange. Yeah, a lot of
like
people have this intuition, and I'd like to me, that doesn't sound obvious at all. Um, like I'm expecting roughly flat recalcitrance. That would be my. Could you what? Can you try to give some arguments for why
uh,
recalcitrance might fall in this way?
Okay. Well, okay. So, I think the primary issue is that you need to like, right? It's like, okay, the current LLMs are extremely good test takers. Like they can recall information from like Wikipedia that they've only read a couple times, like stuff like that, right? They're really good at accessing information and making like a few combinatorial choices. They like piece things together and like you know put functions together and whatever, and that's fundamentally how they solve programming puzzles. So in order to get from 1 hour to 8 hours, you can't get from 1 hour to 8 hours by doing that. I mean, you can try really,
Hmm.
really hard, and if you scale hard enough, you probably could do it. But like, given material constraints, the easiest way is to like actually learn how to code for real, actually.
Hmm.
And human beings obviously do this, and human beings obviously go from copying code to actually learning how to code. But
Hmm.
it's a tough process. And it's like it requires you to actually learn to do the tough things. You can't just be a good test taker. You have to actually learn the material. And I think once they learn how to learn the material, once they get a certain level of introspection and like actual like executive function, once they do that, once they get out of that hump, they can do anything.
Mhm. Yeah, that does sound like a possibility. Um, so, one of the things that perhaps annoys me a bit with this recalcitrance is that the authors of AI 2027 assume, like you and many others, that
Mm.
recalcitrance will fall gradually, and I think it's probably going to stay flat.
Mm.
But the thing is that we get an intelligence
Also,
explosion
the
even if it's
metric,
increasing, right?
yeah, yeah. Well, yeah, it's just like it shifts the distribution, and I think that their distribution, their prediction distribution is really weird, and like I think that
Mm,
shifts it into something more reasonable. But yeah, oh God, I was gonna make a really big point. Um, Crap.
fair. So it's just like it seems like a really poor. Well, so many people have this intuition that I don't share, so I can't really say that it's really poor. But it seems like compared to the optimization power, where there are some really, really strong conceptual arguments for why that is increasing. Like the entire point of AI 2027 is that the
Yeah,
optimization power is increasing, and then you add this really strange that recalcitrance is also going to fall. Um, Kind of
yeah.
unmotivated.
I'm actually gonna play around with the A2027 model with like a distribution of recalcitrance, maybe based off of I'm sure there's data on like what people think about this, and I could just make it up. But it's like I'm pretty sure if you actually use a distribution of recalcitrance, like the ASI timelines become a lot fuzzier. Maybe it extends out to 2030, 2040, 2050 or whatever. And the reality is AI 2037 is like, who cares? That's like a couple presidential cycles away. You're not really gonna get
Mm,
much excitement from that. AI 2027, that's exciting. People are gonna love that. You can get people to do stuff based off of that.
mm, yeah. Um, I think I would agree, but I think also my the thing I would really like for the authors to do is assume that there is no change in recalcitrance. How do the timelines in fact change? My intuition is that they change very, very little. That
I mean, you can literally download the model and play
yeah,
around with it. Like
and
it's
this is
Python code.
yeah, sure. I mean, this is something that ought to be done. I haven't done it. I haven't had time, but this is something that's like my intuition of where it is going to go. Um,
Mm.
so another thing. Let me try to see if I can get the actual paper up. Hold on. Yeah. So I'm sharing my screen, right? I hope I am.
Yep, yep.
So let's see if we can get the actual paper because there is they do try to make some analytical models of here, for instance, they have the equation, and they also try to make the analytical model. Let me see. This one here is an example of like the implicit they're trying to
Oh
calculate this,
crap!
and
Yeah, no. Sorry for interrupting, but
yeah.
yeah, this reminds me of the most important thing, which is
Hmm.
you have these loops, these self-improvement loops, and
Yeah.
it's like they assume it's instant. They assume self-improvement can be instantly applied. Whereas if you make an algorithmic improvement, um, you either have to A, wait until you train the next base model, or B, like apply it to fine tuning, both of
Hmm.
which take time. Like I can't really think of any recent algorithmic improvements that just let you like make inference at a significantly faster pace. Like, have
Hmm.
there been any algorithmic improvements that let you do inference more efficiently? I mean, maybe like you can shift like older models from
We've
like 16-bit to 8-bit precision, but like
Yeah,
other than
we've
that, I
we've
can't think of
certainly
anything.
seen the context windows explode, right?
But all context windows are fundamentally based on base model limitations and maybe like auxiliary stuff, like outside programs.
Mm. But that's an area where we have seen this kind of algorithmic progress pretty
Well,
substantially.
yeah, but in order to actually apply those, you have to train a new base model, I think.
Is that?
I mean,
Yeah. That's interesting. I didn't in fact know that.
and it's like in their model, it takes you like 3 to 6 months to train a frontier model. So it's like you
Yeah.
don't instantly apply your improvements.
Yeah. I think actually that's one of the things that they do in fact talk about substantially, that some of the later models, they end up with models that are improvable on the fly. So that's one of the
Oh, right, the online
qualitative.
learning stuff.
Yeah.
Yeah, the online learning stuff. Like we can literally do that now. There's a reason we don't do it. It's because
Hmm.
like, you want to train the base model first and then do fine tuning because it's
Mm.
like if you like you're trying to because if you try to fine tune it to like be a helpful assistant and then you like try to train it on the
Hmm.
internet again, it's like really messes up the fine tuning process.
Mm. Necessarily, or is that a kind of thing that you could imagine will not hold in the future? It's kind of seems incidental to
Dude,
me.
I could see it go either way, honestly.
Yeah.
But it's like, yeah, I wouldn't be surprised by it. But it's another thing is just like they're assuming these smooth curves when actually they're really, really jagged. And yes,
Mm.
China can
Yeah.
just catch up and win. Look at R1. China made an single algorithm, well, a couple algorithmic improvements. I'm
Hmm.
underselling it. It's a
Yeah.
huge amount of effort, and then they're 10 times more efficient.
Yeah.
Like that can just happen.
I would agree. Like, I think if we take a step back, like Titutel writes in the beginning that he's physicist, and he says this model here is a bad model. And I think if you compare it with the models that are usually used in physics, that is in fact very, very correct. Like these models, if you try to like make a spaceship go to the moon with models of the same quality as is used in AI 2027, you are definitely not going to hit the moon, right? Um,
Yeah, but it's like, Scott Alexander knows what compound interest is. And it's like he
mhm.
didn't really mention that. Like, I don't know. It's just I'm not accusing anyone of anything. I think there's probably nothing, but it's like it's giving me bad vibes, man.
Yeah. Um, so the question is like, if you're saying this is like from the point of view of a physicist, the AI 2027 is a bad model, right? But it's also a fact that it is the best model
Mm.
that we have of AI improvement. Um, it's a different domain from physics, and we are not going to get anything as like when humans are involved and politics are involved and Xi Jinping needs to be modeled to determine whether he will attack Taiwan or something like that, we're not going to get a timeline model that is
I mean,
as good
he's going
as.
to attack. He's going to attack Taiwan. Like,
I mean, my point is that we're not going to get a really strong model, and I think you would probably agree that like there are so
yeah, but
many.
you can get a distribution of models, and it's like they already
Hmm.
have all of these like distributions of like key variables and
Hmm.
assumptions,
Yeah.
and really you really just need to change like 3 or 4 things and
Yeah.
like give a distribution of outcomes and give like sample outcomes and write them up and stuff
Yeah.
like that. But it's like I think the
Hmm.
result of you doing that is that you come away with a completely different conclusion, which encourages an AI race instead of an AI treaty, which I assume the authors of this really didn't want.
Yeah, I mean, I think there is some sense in which this model represents what Daniel Cocotaglio has of like ideas about AI, and there's a sense that he encodes his own biases and worldview into this model. And so the model, the output of this model is something that corresponds to the worldview that he started with, right? But that doesn't mean that the exercise of actually building this model is worthless, right?
Of course, I think that this model provides a lot of value because the other option is nothing. Like at least I have
Yeah,
something to critique,
yeah,
and that leads to good discussions.
yeah. Um, so here on this beautiful screen here, you can see,
Jesus Christ.
yeah, this is one of the things where I think a physicist is like,
Mm,
I'm actually somewhat confused because this is super mega simple. And this is an attempt at making the simple thing that people have been talking about for a long time as complicated as possible. Because this here, let me see, can I actually find here the actual formula? It is somewhere here. Maybe I have the book. Maybe I need to go and actually get the book. Because this here, this chapter has a formula that is precisely the same as this one, just way, way more beautiful. And let me see if I can find it. So it is this one here. That would have been really nice if they actually, uh, had the graph. But it's pretty simple. Otherwise, I can just, uh, see, I have it somewhere on my. Oh, did I stop sharing? I think I stopped sharing by
yep,
accident.
you did.
So I'll just take this back. So, okay, I wrote down some of my own thoughts about this. So, the actual formula that we
Mm,
are looking
mm,
for is this:
mm,
y equals minus ln of capital C minus t. This is
mm,
the actual formula where I have taken all the constants and like merged them together.
mm.
So this is the same thing as we are seeing here. You can see this ln of 1 minus t and then multiply it by a huge amount of things. Um,
Okay, that has to be intentional though, right?
so in Bostrom's book, Superintelligence, it is written like this. And this
Okay.
and here
Mm.
he takes all the parameters and plugs it into, and then he says, "Wow, this is a really bad model because oh my god, this is not the simplest possible thing."
What's nine? The footnote.
The footnote 9 here. I'm not certain of this math, but you get my point about the complexity involved. And I mean, there's a sense that it's true. This looks horribly complex,
Are you
right?
sure it's not like some kind of really complex shit post?
No, I think probably. I mean, this does seem reasonable. This is basically the same thing, except here is the theoretical, conceptual thing where we just put all the units at one, and then we get
Mm.
something really nice and simple,
Hmm.
um, instead um, of this horrible beast here. And like it does seem like if you just say this is our model, then people will say, okay, why not something else? Whereas if you have this precise, simple, conceptually crisp model, then uh, I think the arguments for it are substantially stronger.
Okay, where wh- did does that actually simplify one to one to this, or do you have to actually like swap in constants for some of his variables?
Yeah, like we choose a lot of these constants so they become, so this one, the alpha, this just ends up being like 1, so this cancels out, and we choose h0 in such a way that this cancels out, and then we have all these, like we adjust the units for all of these, so it just ends up being precisely this. As far as I can tell, like it's possible to choose the units such that it's basically this one.
Yeah, and if I if I could fly, I should have wings. Like,
Yeah.
yeah,
um,
you could do
mm,
that, but
mm,
like the whole point of their model is so you can mess around with
yeah.
those
Sure.
variables.
Mm,
You
yeah.
can't just cancel them out and say, actually, it cancels out to 2. So your
Mhm.
model is just an integer.
Yeah, I mean that's of course fair enough, right? The point is that we have for like the past 15 years operated with this formula, and like this is the classic standard way. Like the book Superintelligence is like the classic way uh, to like maybe in September there will be a new version that is even more canonical. But
What there's like no like super common canon. Like you realize we're like basically one of like 200 people who
sure,
even discuss things to this level of complexity. It's like,
yeah,
yeah, we can
yeah,
just
sure,
you can really just do whatever you want, and if it's good, you post on Less Wrong,
hmm,
JD
yeah,
Vance's college Catholic girlfriend, sees it and then like sends it to him, and he's like, whoa. Would you look at that? I'm going to use this to this is going to influence my policy decisions in the future. Like,
hmm,
you know, it doesn't have to like follow conventions that like Nick Bostrom wrote 10 years ago. You can just do
sure,
things.
yeah. And I think I agree with that. The point I'm trying to make is a limited point, which is that when Titotel is saying this is the model and it's extremely complex and it's not something that has any kind of conceptual basis, I think he does in fact say something. I will show that there is no conceptual basis from this. And of course, that's really hard in a blog post to show that no conceptual arguments exist for this. But my point is just that there is, in fact, a substantial conceptual argument for this, which is the one advanced in Bostrom's book, Superintelligence.
Okay.
But I would,
Is there, can we move on to the next point? I
yeah,
mean, I'm not really.
yeah. So, well, I just have some other thoughts that I wanted to say about this. Let me just see if I can go through and see what of this is like for instance, yeah, there's a lot of small things here. Um, Let me just see what I will say about this. Um, yeah, there's a lot of talk about whether you should use the current rate of change or the long run change, where Digital is arguing that we should use the long run rather than what it is right now. Um, when you are trying to like make these kind of estimates, should you go all the way back to 2022, or is there something qualitatively new happening? Let me just see if I can find the arguments for this. And it seems like the argument AI 2027 is in fact that something qualitatively new is happening in that we have recursive self-improvement now that we didn't have a couple of years ago. Here we can see some of the graphs where they are trying to both fit some of uh, the newer and some of the older, I think. No, it's not actually this one. Um, yeah, I think where they're trying to figure out what is the slope of the graph right now. And I think
Oh,
it's
you know what? Crap. Yeah, I think a lot of the it's a lot, I can't quite remember, but I think they might have like had a lot of degrees of freedom for like the SWEE tasks.
mm,
Like they basically, I'm not sure. I think they might have made up some of those, or like they might have used estimates, or like I think they have a lot of freedom to like actually decide the time horizons of the tasks. I think that would have like basically let them influence a lot of these regressions. Explains the straight lines.
yeah, like I would agree that there is almost certainly a substantial amount of like degree of freedom of how this graph is looking in general. But on the other hand, it feels strongly to me
Mm.
intuitively like we are seeing improvement on like roughly this trajectory. And if we have this trajectory, then whether we end up with AI 2027 happening in 2028 doesn't actually matter very much, as far as I can tell.
Well, I would point out another problem is that
Hmm.
we're like crap. Is that in I think it's in one of the papers I read doing the research for this, where the cost of current models, if you run them for like 8 hours or whatever, and like
Hmm.
it, if you run them for a really long time in order to try to match the performance of like a human expert doing ML research stuff, yeah, it's a Rebench one.
Hmm.
Where if you do like best of like 20 or whatever, you can actually get really good, relatively good performance compared to human performance. Not as
Hmm.
good, but like surprisingly good performance. But like
Yeah.
then it gets beyond a certain point, like I think it's best of 30 or whatever, it actually becomes more expensive to use the models than it is to hire a human expert.
Yeah.
So it's like, yeah, a lot of recent gains are from inference, right? It's like, oh, do more chain of thought, do you think more, use more tokens. And
Hmm.
the problem with that is, that's expanding into the budget. Like the more inference you use, the more tokens you use, the more it costs. And it's like right now we're pretty much bumping up against a point where it's becoming a serious issue if you're trying to deploy these models and have them
Hmm.
fulfill. You can't scale inference much more. And it's like going
Hmm.
forward,
Yeah.
we'll probably have to scale back inference because our models will be so big. They'll have so many parameters. The cost just won't be worth it, even for like quite good but not top tier AI
Hmm.
researchers.
Yeah. I think that's pretty likely, but it also seems like the kind of thing which is improving pretty rapidly. Like the uh,
What I'm trying to say is that our
mhm,
improvements over the past year have
mhm,
just been like eating heavily into our budget. Like you
yeah,
only get this increase once, and then you don't get it anymore. You'll have to work on it the hard way. You have to do it through like
mhm,
harder algorithmic improvement pathways,
yeah.
right? It's so like the recent trend of increasing performance won't hold.
Mhm. So here, for instance, Measure is saying that, yeah, if you just look briefly, they find a 3.5 month doubling compared to 7 month if you go all the way back to 2019. Um, so they say that may be because agency training was scaled up or something like that, which is like another kind of like maybe a one-time thing, but it's possible that we can continue to find more of these kind of one-time boosts, right?
I
Like,
mean,
like we found one boost by using more time on inference, and we've also found a one-time boost from agency scaling up agency training, and maybe in 6 months we'll find another one-time boost. And if we get enough one-time boosts, eventually we will have like then it will end up being like not one time. Does that make sense?
man, it's like well, there's a lot of overlap between increasing inference and agency training, though. And
Hmm.
it's like, I don't, it's like, okay, a year ago, you could say, okay, well, here's all these unpicked low-hanging fruits of agency and scaling of inference and chain of thought, so on and so forth.
Hmm.
But, from our current perspective, it's like, okay, we did those two obvious low-hanging fruits. There's no more obvious low-hanging fruits for us to pick in quite the same way. So, in the world where, okay, there are similar low-hanging fruits, we don't really see them.
So all these things, the low-hanging fruits can't have been that low-hanging because we didn't do them in 2021, right? So they can't be that low-hanging.
Well, Well, we trained GPT-4 and then we tried train and then OpenAI tried training GPT-5. If that had like actually worked and caused like a huge performance increase, we would be talking about the low-hanging fruit of like scaling up our models even more. Instead, like
Mm, yeah.
like you could have predicted from like 2023, 2022 that like something like chain of thought inference increasing inference would give you improved performance. Like I
Mm.
I think yeah I would there are definitely people who made predictions like that in 2020.
Okay, here's another way that I could try to say the same. Assume that you have just figured out an algorithmic improvement to a large language model, right? And then after you've made that, then I can say to you, hey, Lau Mein, this is actually a one-time thing. Because once you've implemented your improvement, then you can't implement it again. So there's a
Well,
sense
yeah,
that.
but that's an entirely different regime because it requires a huge amount of research to actually find those. R1,
Mhm,
sorry, DeepSeek did a huge amount of like algorithmic research in order to actually find those.
mhm,
It's like, but it's like, but you could have said ahead of time, oh, okay, like those algorithmic increases are unpredictable.
mhm.
Sorry, what were we even arguing about? I generally don't know.
Yeah, I'm arguing that pointing to a number of improvements and saying, "Hey, these are one-time boosts," isn't that meaningful because all improvements in practice are going to be like one-time boosts. And the fact that we are seeing a huge number of one-time boosts means that this entire framing of one-time boosts is pretty bad. You should think of it as like an improvement process because you've seen so many one-time boosts and you're probably going to see more one-time boosts.
Well, I mean, I think there's certainly two domains of one-time boost. One's where it's like, okay, people were aware of these like 5 years ago or whatever, and it's like, okay, you can scale up your models. You can use like specialized hardware to train your models. You can use specialized hardware for inference. Like there are these things that are obvious a while back, and it's like we've used
Mhm.
up so many one-time boosts and we don't like
Mhm.
we've found some that we weren't aware of 5 years ago, but from our current perspective, like there are so many fewer obvious one-time boosts than were a few years ago. And it's like,
Mhm. Yeah.
we're getting to the point where it's like material limitations mean that there's only one avenue of advance left, and that's just hard algorithmic research.
Yeah.
Um, and that means we slow down in the near future.
Yeah.
Would kind of introducing like improvements to semiconductors be helpful here in the sense that,
Where
Moore's law has,
we've basically done all of that. Like, what do you have in mind?
well, what I'm saying is that if people for a long time have been saying like Moore's law is going to end, Moore's law is going to end, and I mean, arguably it has slowed down, but I
I
guess
mean,
that
are
the
you aware of
demise
the
has been
fact?
announced way before because
Are
people are like,
you
oh yeah, we've already done this, we've already done this,
are you
but
aware that 4 nanometer architecture doesn't actually mean 4 nanometer architecture? Like all the nanometer things are literally just advertising now. Like they're just completely made up, and they have the number go down every couple of years, so people like are excited.
I could imagine that, yeah. But and I mean, I would argue that improvement has now slowed. But also, I remember 20 years ago when people saying like this can't continue, improvement must slow, and it did continue to improve for a good 10 years. So what I'm thinking is that the fact that we don't see immediate improvements is not like very good, like that they can be done is not very good evidence for it being unlikely that future improvements are done, at least in the case of semiconductors.
I agree. I just wanted to jump on top of that thought. Like rocking even where you can see like poor levels of performance and then like at just the seemingly the snap of a finger like the model just gets the underlying concept and I understand like scaling laws like aren't like a hard law, right? But I just don't like I don't think you can draw any fundamental conclusions about um, future capabilities
Well,
when
there is one thing you can draw firm conclusions on, and the AI 2027 people more or less agree with me, is that hardware scaling is like actually extremely predictable. Like they had this model where it's like, okay, given the past um, uh, performance of like NVIDIA, how many chips they produce every year. Like it seems that they're only doubling chip production every year instead of like doing things any faster. So like when you're trying to predict things 2 or 3 or 4 years in the future, you can say, okay, let's say they only double every year. You know, that gives you a relatively reasonable prediction for future hardware availability. Um, Whereas, for algorithmic improvements, like, I don't know, maybe they find a 100x thing tomorrow. Like, there's so many
Totally.
Uh,
inefficiency in systems that's completely possible.
Yeah, I'm just like, I guess with reference to like the benchmarks that you were critiquing, what like length of task?
Mhm.
Like I wouldn't be surprised if scaling for the next 2 years revealed like very little improvement, and I also wouldn't be surprised if scaling for the next 2 years yielded like massive improvements. Like I
Yeah, yeah, I
okay.
pretty much agree with that.
I think I would like to make a conceptual argument for why we should expect dramatically faster improvement than that.
Okay.
So, what goes into making the next generation of chips? A number of things goes into that, but one of the key inputs is engineering hours from the people who designed the previous generation of chips, right? There are more than that. There's
Hmm.
also material science and probably some basic research being done outside of the labs. But the key thing that is required is engineering hours. Is there a general agreement with that?
Unsure, and I'm unsure where that, like,
The idea, of course, is that if the engineers are more or less running on the hardware that they are building, because
right.
a lot of the engineering hours that are coming into the design of the next generation is done by AI.
Hmm.
If it is the case that a substantial amount of like in the limit where it's like 100%, right? If it's 100% engineering hours that is being done by AI and it's the only thing going into it, then you would expect with Moore's law that the first generation takes like 18 months, but then the AIs run twice as fast, and then the next generation comes after 9 months, and then 4.5 months, because now they are running on twice as fast chips as well, right?
Okay, here's a counterpoint. For hardware, if okay, if you say that, I'm going to make an argument that I'm not sure I even believe this, that ML research is roughly as difficult for humans as chip design,
Hmm.
and that if you could do that with chips, you could do it with algorithmic improvements,
Yeah.
and algorithmic improvements can be applied like a couple months faster than hardware
Mm.
improvements. So if hardware improvements, like you say, were possible, you
Hmm.
would like probably get to an intelligence explosion before they can be applied.
Yeah. Okay. So you just said it, that the situation is even worse in that case. Um,
Well, yeah, yeah, and but it's like if we were at that point and we're not,
mhm.
it's like okay, once you get to once AIs can perform like extremely complex frontier scientific tasks, then yeah, obviously you get an intelligence explosion, assuming that you can run them cheaply enough. Like obviously that's true.
Mm. Well, one important thing about Chichitel is that he is saying that this is one of the explicit assumptions of this paper. Here, I think I have it on the screen here. Like they assume this is true and apply it to every model. Um, so this assumption that we get this feedback loop, and I agree, it is like it's the core part of the AI 2027. Um, but it's also, Tijutel certainly does not consider this obviously true in the way that I do, and that you maybe also did just before.
Uh, that they're able to use the AI for R&D improvements.
Yeah,
I mean,
then
it's like it's about definitions. It's like they assume that we're already on the ladder. It's like, how do I say this? Um, uh, it's like, okay, imagine the Industrial Revolution from the point of like 1820, right? You can say, well, once you get once you get machines that like automate labor, like eventually you'll be able to like automate labor. You'll be able to like automate increasingly complex labor and like say that and make oh crap, what am I trying to say? And you can say, okay, scientific research requires labor, right?
mhm.
Machines can now do labor. Eventually, machines will contribute more and more to scientific development. Therefore, we'll get like an immediate takeoff in the next 50 years. Like, it's entirely possible, but and it's true to a degree. Like, obviously, you free up more people from farming, and they do more scientific research. Obviously, like having like electricity and automated lathes and workshops and stuff like that helps people do more research. But like that maxes out at a certain point. We went to diminishing returns. So it turns out that no, having the steam engine doesn't mean you automatically get an intelligence explosion, even though
Yeah,
you can use the steam engine for better research. And it's like,
yeah. Well,
well,
because
maybe
you,
our current, but maybe like the recursive self-improvement we're seeing right now where okay AIs are good research assistants, they help you research, maybe that maxes out like maybe that's already maxed out or whatever, or we're close to maxing it out, and like in order to actually get to like really big recursive self-improvement where it's like okay maybe we only get 3x like a researcher output like for the foreseeable future, but like you could get more, but it
mm,
just you need to do something else.
yeah. So just real quickly, the answer to the 1820 Industrial Revolution argument, if
Mhm.
someone had predicted an intelligence explosion there, then the my answer to that would be that you are not going to get an intelligence explosion in 1820 because the steam engines cannot,
Mhm.
in fact, do research and development on steam engines. So the core thing that
Well,
needs to be
see well, they do help people. They do improve the output of steam engine researchers, obviously,
kind of
because like
indirectly, yeah, but they
well, they
can't
do
actually
directly
do.
because like it turns out that having like a workshop and like being able to move really heavy engines around a lot, that like maybe it genuinely did double the productivity of like steam engine research or even triple it or hell even 10x it. Like it's entirely possible that's true, and also that's where it stops until you get to the next paradigm.
Yeah, I mean, it did like remove a number of blockers. The Industrial Revolution, like suddenly there was it was possible to employ more researchers. So in that sense, it did help, but it didn't help on like the core loop, which is
And current AI assistants don't help on the core loop. Problem is, I'm not sure what the core loop is. I don't think anyone really actually knows
mm,
what the core loop is. I
yeah.
put significant probability mass that like, okay, yeah, no, we're on a hard takeoff right now, and like,
Mhm.
we just directly head into the singularity. But I also put significant probability mass on like, actually, these things need to get executive capabilities, and like, they actually need to get good at coding and not just copy and pasting code. And it's like in order to get there, it's like you have to. It might take you 5 to 10 years. Like I think it's well, 10, maybe not 10 years, but like I think that's entirely possible.
So the way the authors of AI 2027 operationalizes this is with the term research taste, which is the key thing
Mhm.
that the best AI researchers have, that the models don't have yet, and that they are gradually acquiring. How do you feel about that operationalization? Taste, research taste, is that good?
I'm gonna give a shrug and say it's entirely possible. Tomorrow we get an AI with like vastly superhuman research taste, and also like it can't code.
Hmm.
Like it can't actually code and just like copy paste code. Like I think that's possible.
Yeah. So once
For
we have
context, GPT-5 was released a few hours ago.
seriously?
That's what we're waiting.
Oh, well, then
Yeah.
we'll have to see whether it has.
I mean, from what I read, it's the, like incremental improvement kind of thing. Just sorry, I didn't want to fully derail, but like, no, this does not appear to be explosive.
Okay.
I mean, sure,
Okay,
I'm
yeah.
not,
So that's why they were vague posting. They knew it was
Yeah.
shit. They were trying to
I mean,
show.
no, I'm not saying it's like GPT 4.5 type deception. Like, look, I've read
Mhm.
one article about it, but I'm just saying I read about it. Yep, it's new stuff.
Oh,
It's cheaper. It's O3 plus. It works. But
interesting.
anyways,
Yeah.
I'm sure Shvi will have something about it within 24 hours, and we can read about it.
Yeah.
I'm just saying tomorrow is not going to explode, probably.
Well, I'm
Well,
not convinced. I'm not convinced at
well, I
all.
mean, they've already deployed it internally for a while. That's why
Almost certainly.
everyone was vague posting.
Yeah, probably. Huh. Oh well, we'll see.
Well, talk about incremental. Jesus, that's not.
Well, that was certainly a thing. Uh, but like, I think the question here is like, as long as it's improving, then it seems we are on on a track to an intelligence explosion, right? As long as it
I'm not
keeps.
sure that's like technically true, but I'm not convinced that we're not on track. I mean, you can improve um, logarithmically, I guess. I'm not sure how
Yeah,
to say that.
sure.
Sublinearly,
Yeah.
which we are in a way. And like comparing, if you're looking at like the amount of compute we put in stuff, Toby
Yeah.
Ord was talking about that recently. Just the idea, like, oh yeah, they've gotten better. We got to put so much more effort into them, and in that sense, it's not like super great. Then again, like cost wise, it's not that much more.
Hmm.
Um, but at some point you can say like, yeah, it keeps improving, but it doesn't improve fast enough to like warrant the economics. And in that case, we could not get a takeoff for a while.
Yeah.
We could also just kind of run out of money in a way.
Hmm.
Oh, can one of you guys extract a tokenizer for GPT-5?
That's a good question. I don't know.
I'm
I
afraid
think
not.
you.
And also, I had to log out. Sorry. So
Okay.
thanks
Oh
for
yeah,
the talk.
goodbye.
Yeah.
Bye.
Thank you.
Yep, no problem. Jesus, it's so late.
Then I guess the thing we could say up is next time. Nick Bostrom has
Yeah.
written a new paper, Open Global Investment.
Uh, oh, I was going to continue like the
Yeah.
AI 2027, but like I feel like we've
Oh,
already talked about most of the things I want to talk about. So it's like if
yeah.
you want something else, I'm fine with that too.
Yeah. Let me see if there's something that that's a good question whether we want. I didn't actually realize that you wanted to split yours into two.
Yeah,
That's
I realized that pretty late.
yeah, fair. Um, so let's say what else do I have here? Like um, here, log normal sampling. How much would that expect? We would expect that to affect the results.
That was stuff like that is actual research I plan on doing.
Yeah, like if you plan on doing that research, then I am going to register a prediction that that is not going to change very much. Yeah,
No,
I
I
should.
would say that's basically okay. Wait, log normal sampling. That's what does that remind me?
It means like when you sample some of the parameters, then you can just
Uh,
sample them in like a standard linear. So like you can have 1 to 10 and like 100, and they have like the if you want them to have the same probabilities, 1, 110, or you could just have like linear where you when you sample the uh,
yeah, I would probably agree because I think it's just most of the difference would be driven by like a few key factors like recalcitrance.
yeah. So one
Actually, could you send me a list of like research questions about AI 2027 in text form so like I don't forget?
yeah, let's write some in the chat. I think I can do that, right? Let me open the chat and see some of the so Søren's
Oh,
predictions.
Okay, no,
Yeah,
it's
questions. You can see what I'm writing, right? So there
yep.
is um, um, constant recalcitrance um, uh, only pushes out timelines a tiny bit. Small positive recalcitrance, which is the assumptions, also only pushes timelines out a bit. But of course, a bit more, right? Log normal sampling doesn't doesn't change anything. That's of course when I write that this doesn't change anything, then that's like if it doesn't literally doesn't change anything, then almost certainly we will have written something wrong, right? So
Counter prediction, recalcitrance basically drives almost all the differences between the model
we have a
distribution.
substantial difference in expectations then. That is wonderful. I don't know if we should bet. I think that's I have, but I think that's probably too. But I'm happy
Yeah,
that we
see,
have disagreements.
that's the problem with betting with you is that like, I've been awake for 20 hours, and
I mean,
you
fair.
know,
It's good to write down your predictions, and
yeah.
that's totally fair. Um, so, uh, yeah, what is my next kind of assumption? And that is, let me see what I can find here. Uh, um, yeah, the question, of course, um, is the long big formula actually so more big to y equals minus ln of c minus t.
I
Uh,
think you could answer that probably.
I will need to look more into it to actually be sure. I'm not entirely sure.
Okay. I mean,
Uh,
like you've actually looked into it. I haven't looked into it at all.
yeah, sure. Um, um, mm, so yeah, here um, there's a there is a change in models halfway. I think I can't remember the actual time. Um, uh, if one does not change models, performance grows too quickly, and the scenario just ends uh, too fast.
What do you mean?
Yeah. So they use different models for how the AI improvement actually happens. And at some point, I can't remember the actual date of the model, then they kind of shift from one model of improvement to another. And as far as I can tell, if they continue to use the original model throughout and don't change models, then the performance just grows and grows and grows and even faster, and we reach a singularity even earlier. And all these wonderful things they write for 2028, 2029, 2030 doesn't end up happening because the AI just becomes way too smart for this. That's what
Huh.
I'm trying to say here. That
Yeah, yeah, no, that, that
they
that sounds about right.
yeah, like they have to really um, uh, like push their models in a specific direction because otherwise things get too crazy too fast.
Well, I think it's fundamentally like, again, do you think that they're like, my hunch is right about them heavily using this to push for AI treaties as opposed like they like maybe they fudge things around the edges and like make assumptions like that that aren't completely warranted in order to encourage like AI treaties as opposed
Hmm.
to a race scenario, which would like
Hmm.
like a more straightforward prediction, more um, you know correct prediction from their point of view might be that the rational thing for US and China to do would be to race.
Mm, I think on principle, I don't want to speculate about the interior thoughts of Daniel Cotallo. Like,
Yeah.
um, I think there is a strong sense where this is the simplest model. I will write this as a production. There is a strong sense in which the model presented in AI 2027 is the simplest.
That is
So
hell of a prediction.
that is, in fact, a big prediction. Yeah. So, what else? Um,
Hmm.
yeah, there was some talk about whether there was
Hmm.
bigger or smaller differences between the public and internal models, and
Uh,
yeah, and
it's like
they ended up
I'm
removing
not
that.
really sure what they're arguing about that. Like because I
Yeah.
would assume that it would wait, I in their model I think it does grow massively because like the frontier corporations stopped releasing models. And it's
Hmm.
like the like runner ups that release like all the stuff people are using.
Hmm. Yeah. Um, I
I'm
agree
actually
with
not
you.
really sure what this was even about.
Yeah, like I think the idea was that if there are more capable models being hidden, then it's possible that the actual development is faster than we expect.
Well, I mean, we actually know for sure. Like, GP5 just got released and it was kind of shit. So,
Yeah.
uh,
We don't actually know what models OpenAI are using internally, right?
that is true.
So it is in fact possible they have something dramatically better. We just don't know.
Well, I mean, if they do though, like, you know, I think they would like. I think the world would look different. I think they would have released a better model for one.
Possibly. I mean, it's. I have a hard time figuring this out. I think.
Actually, you know what? Let's actually bet some money. What do you think are the odds that they're still using the same base model as GPT-4 and friends?
Internally?
No, for GPT-5. Do you think
Oh, that there's
GPT-5 is using
the same
the
model.
same base model as O1?
Oh, that's interesting. It's kind of hard to bet on that because I haven't seen the announcement for GPT-5. Like you've been seeing my screen. Like I literally haven't alt tapped to Sam Altman's Twitter or whatever. So I haven't seen the announcement. I think I am 75% that they have a new base model. Because I
Mm,
feel if they reuse the base model and call it GPT-5, I mean that's really cheating, right? There's gonna be no end to people. I would expect them to have a new base model. Yeah,
yeah, but performance gains are marginal.
that is an argument in the other direction. Yeah, that is some evidence.
Actually, no,
Um,
holy shit. If they have a new model, a new base model, like
mm,
presumably that's what they've been spending the compute for like the last 2 years on. Like if they have a new base model and the performance gains are marginal,
yeah,
like
that makes my
that
timelines
means I
longer.
was right. That means I was right and they're hitting a
Mhm.
plateau.
That does in fact suggest some kind of plateau. Yeah, that's going to be really interesting. Tomorrow, Twitter is going to be a buzz with saying, "Have we reached the plateau?" And yeah, it is in fact possible that I guess there's a 50% chance they are above my expectations and a 50% chance that they are below my expectations. So if I'm properly calibrated, which I'm not.
Well,
Um,
no, you already have information now,
yeah,
and
I have
like you
like
should.
the information that I think Olivia said was that it was lackluster, which is interesting. And that does in fact point towards longer timelines. I yeah, I am not
I
really
need
happy
to
about
sleep.
betting without knowing anything else. Uh,
Yeah, yeah, no problem.
let's see, anything else?
Oh yeah, I like obviously like I will only offer a bet that I thought I would win.
Fair. Um,
Is there anything else,
let me
or
just.
should I like
Nah, I'm just
sleep?
go. I think. Let me just see if there's anything I. Um, yeah.
Assuming RSI has been going on since 2022, then this must be very slow 1.17. Like,
Yeah.
such bad framing. I
Uh,
would go back to the steam engine thing where it's like, obviously, an AI assistant that can like
mm,
tell you what a
yeah.
segment tree is different from one that can like actually do frontier research.
Yeah. So let me just find the argument where it's at 1.17 here. Here. So if you assume that this has been going on since 2022, this recursive self-improvement that we're seeing now, then the model says that then the recursive self-improvement must have been really, really slow if it's been going on for the past 3 years and hasn't resulted in an intelligence explosion. Uh, which is, I mean, true, but then the obvious answer to that is that recursive self-improvement has in fact not been going on since 2022.
I think we need like as a research community need a better term than recursive self-improvement because we
Hmm.
need to distinguish between the steam engine scenario and like actual intelligence explosion.
Yeah.
What would you call the two different things?
Uh, could you restate the question, please?
Okay, so I think there are fundamentally two different types of like ways that a particular tool can contribute to
Hmm.
increasing research. One where it's like being used as a tool to remove some blockers, but like it's I think it's the difference is one form of recursive self-improvement takes you directly
Hmm.
into the trajectory of removing all blockers, whereas the other one means that like you go to a certain point, you hit a blocker, and then the recursive self-improvement stops.
Yeah. So here we have an example where it starts at like infinitesimal helping, and then helps more and more and more and more and more until it helps 50% at this level, and then it helps like entirely, right? So here it's
Mm.
very smooth in this graph. Um, in I think Ilya in the paper, The Microeconomics
Mm.
of an Intelligence Explosion, calls it that it fizzles out because it's only able to improve within a small
Mm.
domain, and then it improves itself within this particular small domain, but it doesn't actually cover the central challenges of intelligence improvement. So I think
Okay.
uh, an explosion that fizzles, it's something that a takeoff that fizzles out.
Yeah. Versus like one that reaches singularity or
Yeah,
whatever. Yeah.
yeah.
Sounds reasonable. Is there anything else?
No. Uh, but we didn't quite figure out. Uh, should we have? Would you like to continue this topic in 2 weeks?
Yep.
Um,
I would. Same time.
yeah. That would be great.
Okay.
Yeah.
Okay. No problem. I need to go to bed like right away. I'm sorry.
Okay. Yeah. Fair
Goodbye.
enough. Goodbye. Well, um, that was. Let me just pause the video recording. Um, so there will be more AI 2020.